Okay, so welcome all of you. The Android LX Meetup is back, and today we have two awesome talks and two awesome speakers, Marcelo and Diogo. I'd like to thank Andrea and Farfetch for providing us the space and the food. And Andrea, if you want to say something.
Briefly explain to you what Farfetch is. So we're Portuguese company, a marketplace. We started as a marketplace, and nowadays we're way more than that. So we're a platform for fashion brands and boutiques. If you're wondering, no, we don't have an Android team here. We have an iOS team that works in the Store of the Future project, which is basically technology that we're developing to minimize the gap that exists today between the online and the offline world. Nevertheless, we do have Android, so the marketplace serves has a web version, of course, and then we have the mobile apps. They are both available Android and iOS. Our team is based in Porto, but we're most welcome to have you all here in Lisbon as well. Okay, thank you.
So without further ado, I'd like to invite Marcelo to jump in and.
Okay. Thanks for being here, guys. So my presentation is going to be about Dagger 2. Probably you heard of it already. It's quite popular. Maybe it's becoming less popular right now. I don't know. And there are already many talks about it, many articles about it, and seems to me that still many people don't understand how it works or find it complicated. So the goal of the talk is to try to explain how it works and also a pattern how to use it. So short information about me. I'm currently working at Talkdesk and as an Android developer. And previously I worked in Aptoide here. So I'm living in Lisbon for 1 year and a half already. And yeah, nothing else to say about it. So I expect you guys to know that already. It's a definition of basically what we're trying to achieve with Dagger. And it's dependency injection. So dependency injection is a technique whereby one object supplies the dependencies of another object. I'm not going to talk about the advantages of that, but I expect from the bottom of my heart that you know, because that is the reason why you use Dagger if you use Dagger. Actually, who here uses Dagger? Dagger 2? Dagger 1? Any other dependency? Dagger 1? Okay. And any other dependency injection framework for Android? Good. Nice. So yeah, the first question is Dagger 1 or Dagger 2, but actually Dagger 1 is deprecated. It was deprecated by Square, the original creator of Dagger. I don't know if I agree with that deprecation, but let's see why would you go for Dagger 2. Compared to Dagger 1, Dagger 2 has a better performance, mainly because it doesn't use reflection, what Dagger 1 used to do. And so it's the first implementation that implement the full stack with generated code. This is nice because reflection is kind of a magical thing and a slow thing as well, and it hides how things work, and it's hard to debug when you have reflection in your code. And since it generates the code in compile time, you can check what's going on and debug easily. Also, it's really easy to use ProGuard with that. What was not the case with Dagger 1. It was because of reflection, again. Compared to Dagger 1, it's harder to replace the dependencies for testing with Dagger 2. Actually, it's quite hard. We are going to talk about it. In my opinion, it is hard compared to Dagger 1, but and it's way more complex. It's complex, and Dagger 1 is so simple. Sometimes you forget about it if you used to use Dagger 1 and then you switch. I switched a long time ago. and I forgot how simple Dagger 1 is. So compared to Dagger 2. Okay, but yeah, why? I think everybody should ask this question before introducing a external dependency to their source code, and we should also ask this question before integrating Dagger. So yeah, the main, in my opinion, and this talk will be a lot about my opinion, guys. We're going to talk about it afterwards. The main advantage of using Dagger is that we don't have access to the constructors. Don't have access, I mean, we are not responsible in Android to instantiate the Android components. The OS does that for us. So we don't have access to that, and it's hard because of that to do dependency injection in Android. So Dagger solves this problem. It also helps you with dealing with the life cycle of your object. So how long this object should be living in memory, and then I don't want it anymore, and you deal with that with scopes. Yeah, it eases the replacement of dependencies for functional UI testing, but eases compared to not having anything to help you with that, but it's not that easy. And the last bullet, if you probably, I did at least when the first time I heard about Dagger 1, I watched a talk of Jesse Wilson from Square about Dagger 1. And the main advantage that he highlights is that it standardizes the object creation of in your application, because I think he was referring to large backend Java applications. And I don't think that's the main advantage for Android. If you have a big team, I think maybe it is, because then everybody has a standard how to do things, and then it's better to limit sometimes the imagination of people. Okay, why not Dagger? It has a steep learning curve, so if your team is not used to the concept or never worked with something similar, it may take a while for them to understand how it works. It has a lot of features that, in my opinion, for Android, they don't matter. You shouldn't use them. It may cause performance problems, but I mean, this problem was mitigated with the second version because there's no reflection anymore. But still, if you misuse, if you inject everything at once at the beginning, you may have some performance problem. It easily leaks all around your application, and once it does, it's really hard to replace it, and then you have to stick to it. So you have to be careful how, and we're going to talk about it as well, how we can isolate it a little, and it's hard to get rid of Dagger because of that. Okay, let's talk how to use it. Yeah. The point here is to not have magic. I like this. That's why I put in all presentations. Funny. Okay. So how to use Dagger, and then when you think about it, all these questions come up, like should I use this new module that they created called specifically for Android? Should I use inject annotated constructor, or always provides annotated methods? How many components? How do I group my classes in modules, and all this? How do I use scopes? Should I use this smooth binding thing, producer, subcomponents? Too many options. So because of that many options, you need a pattern. I mean, I think it's good to have one. And this talk is about this pattern. This pattern is my opinion on how to use it, and how previously I tried to do it. So, I mean, you may disagree about it, but it can be used as a reference. Okay, so this is summarizes what we're going to talk about. Dagger solves only the Android component problem. Then the problem that we cannot inject the dependence in Android components. That's the only thing we're going to solve with this library. That's the reason why we always use producers in modules and never inject in constructors. Because if we use it, we're going to be doing it without need. Because If you have a constructor, you can inject through the constructor, and there's no need to use Dagger. So always produce instead of injecting constructors. The inject annotation only goes in attributes attributes in Android components. We have an application component, an activity component, as an activity subcomponent of application, a fragment subcomponent of activity, some base classes to help us inject, and 3 scopes: application scope, activity scope, and fragment scope, and modules based on our architecture. And more on that later, obviously. So architecture, we have to define one. And so I'm a fan of clean architecture. I'm not a fan of the boilerplate code of clean architecture. I'm a fan of the principles. And here we have the principles. We have entities, simple objects that describe some business logic. And then interactors where we have the use cases. And then presenters. I choose here to use presenters, but it's just we're going for MVP in this presentation, but it doesn't matter. You can use MVVM or whatever for the view layer. And gateways. And the dependency point, the source code dependency direction is that. So entities don't know about interactors don't know about presenters, and presenters don't know about the details of the application. So the details are important. The details are all these external services that we need to use, so we don't need to write to rewrite the wheel and all that. And Dagger is a detail. Since Dagger is a detail, it shouldn't be all over your application. It should be abstract as much as we can. Okay, we need an example. So our example will be a simple application that displays a list of contacts that you have in your phone. So just grab the contacts that you have in your phone and present, and then you have a detail of the contact. But I won't show any UI, it's just a concept. Okay, finally, I'm going to start showing code. So yeah, let's create our application scope. The annotation, some people use singleton. That's annotation that already exists in the JavaX package, I guess, and you have available, but I will use application scope to show it's the scope. If you annotate with that scope, it means that the object will leave as long as the application component leaves, or the application leaves, if you annotate with that method. Forever, it's strong. As long as your process leaves, yes. So yeah, there's no process anymore, there's no VM anymore, there's no objects anymore. Forever. Okay, so we create application component. This talk is not like for beginners, so I expect you to know a little bit about it because I'm not going to spend a lot of time explaining it. But yeah, you have the application component that will hold the instances, the objects that will leave as long as the application leaves. So when we create this interface, afterwards Dagger will generate code for that. And when we create this interface, we say to Dagger that we want to satisfy the dependencies using modules. And now they come, the modules associated with our architecture. The interactor module will describe how to configure and instantiate the interactors. And the gateway module will explain how to configure and instantiate the gateway implementations. Okay, so I talked about the base class. They will help the other, in our case, the only application class we will have. And the base application will then use the generated class. Dagger just generated when I built. You saw that there was a component, an interface. The name of the component was application component, so it created Dagger application component builder for me. It knew that there was an interactor module declared, so he's asking for it. He knew that there was a gateway module declared there, so he's asking for it in the builder. So I'm providing it, creating the component, and this is important. I created it. I have the component. The guy who will hold the instances of that I will generate with the modules. This guy will hold them. And I want them to leave as long as the application leaves. That's why I keep the reference of the application component in the base application. So I'll make sure that this object will leave as long as the base application will leave. There's no magic here. I need to take care of the life cycle of my components. I define the life cycle of my components, and I decided that this one will leave as long as the application lives. Okay, so here's the module, straightforward. Like I said, all the dependents will be satisfied here. No injecting constructors. So the interactor module will have, for example, the context interactor, and it will have an annotation saying that it belongs to the application scope. It means that once someone requests a context interactor, it will be instantiated, and afterwards, it will be always the same, as long as the application component is the same, and I make sure that it is. So someone requests, I'll give the same one, the same context interactor after the first time. And the interesting point here is that this module will say, this provides method will say that it depends on the context gateway. And there's no provide here for context gateway. But since we declare in the application component that we have the context gateway, the gateway module, here I go, yes, it is, satisfies the dependency of the context gateway. The interesting part here is that this module has a property in the constructor, so a dependency itself, that's the application. Because in our case, the context gateway interface will be satisfied by a content resolver context gateway. That's a guy who will use the content resolver to grab the context information from the device. So we can have dependencies in modules. So if I go back, you will see that I'm using this, I'm passing this in the gateway module. That's the application. I need it to have the content resolver here. Okay, so finally, my application will inherit from base application. And since base application exposes to me as a variable the component, I can grab it and inject myself. And then you can have it. Since context application is an Android component, no worries, I can have the inject annotation there to describe the fields that I want to be injected. In this case, the context interactor. So just inject myself, and Dagger will look. And there's an important thing about it. This is just, I created a setup method there in the interactor just to justify the reason why I need the instance here in the application. Usually you have set that in some of your interactors, you can have it. Okay, are you okay? Simple? Good. So yeah, I have to update my application component with the inject method that's being called in the previous slide. So here I'm injecting context application here, this. So I need to go to my application component and update it with this function that will have exactly the type of context application, because Dagger 2, there's no magic. He needs to know the types. And it's really easy to get confused about it. So you may want to reuse this method because of inheritance or anything like that. Someone like, if you had another object that inherits from context application, the IDE would suggest you to use the same inject method, but you can't. because Dagger will get confused, doesn't understand. He needs the specific type of the class where the objects will be injected. It needs the type. Okay, so we talked about our business logic, interactors. Now we're going to talk about the presentation layer of our imaginary application. And we are going to use MVP for that. And we are going to have like an activity that is just a container. I like to have activities as containers and have the views always presented using fragments. It's another opinion. So we have a list fragment and a detail fragment. And we have a list presenter, contact list presenter, contact list, contact detail presenter. Okay, here we go again. Another scope. This scope means that, again, if I annotate a provides method with that scope, the object will leave as long as the activity leaves. So we have a different life cycle for this object. So another component. Here this is like I'm not following. I told you guys that the modules would follow the architecture, but this is like a helper module, the navigator module. Because I don't know if you do that, but my presenters have a reference to a navigator class. So when I want to go to view A to view B, I just say navigator navigate. And I don't know if view B is a fragment or an activity or whatever. It abstracts that from me. And the funny thing is that, let's talk about the funny thing afterward. So my base activity that will help me to inject my dependencies. And here's the funny part. It will be, oh, forgot to say that this is a subcomponent. The annotation is different, not a component. So it will be a subcomponent of a component. In our case, the application component. So I'll go there, I'll grab it, and then I create this plus method I'll show afterwards and pass the navigator module, and then I have the activity component. There's an interesting thing about this code is that the onCreate super method is called afterwards. First, I instantiate the component, and afterwards I call the onCreate method. And there's a reason for that. It's because when you have a configuration change or in your activity, like rotating the device, or if you have a fragment declared in the XML of the activity, like statically declared, when I call super, it gets created. And I don't want it to get created before I have the component, because our fragment will depend on that component. It will be a subcomponent of activity component. So I have to make sure the activity component is there, not null, or I will get a null pointer exception, before I call the super on create. Of course. Yeah, that's good that you said that. No, I'll maybe I would forgot about. We would discuss that afterwards, but it's because the component that holds those instances is destroyed, because the activity itself is destroyed. So I can show you in the this is the basic activity, of course. Even I didn't put it here because it would be too verbose, but I like to do what I like to do is to set this component to null in the onDestroy. So it will eagerly say to the garbage collector, man, I don't need it. This guy, remember, the component is the guy who is pointing to the dependency. So as long as no one is pointing to it, the garbage collector can then grab this memory back. So when the activity is destroyed, the system is not pointing to it anymore. So no one, and the activity is pointing to the component, but it doesn't matter because no one is pointing to it. So everybody is going to be garbage collected, including the components. Dagger doesn't wait for anything. Dagger doesn't do that. The reason why it happens, because this guy will be destroyed together with this guy. And I choose to have this guy here. It will never happen to the application component because he's there in the application. It never gets destroyed. Okay. Okay, yeah. So I told you guys about the plus method. It goes in the application component. So I choose to call it plus, just a convention. It could be blah, 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 or whatever you want. Okay. So it plus. Actually, I don't know, but yeah, probably it's a convention. I call it plus, and then this is important. I have to put here the navigation module because it is a dependency to create the activity component. Because here there's no builder, so I have to provide right away whatever that my activity component needs to instantiate its objects. Yeah, that's component plus, and I have to pass the navigator module. So here's my module, navigator module. It's, again, there's a scope there saying that it will be created once, like the first time someone requires it by the .inject annotation, it will be created, and then as long as the activity component, and because what we did, the activity leaves, it will be the same instance. Yeah, here I do the same strategy that I did with the content resolver thing. I have the activity as a parameter of the constructor of navigator module, so I can have access to the fragment manager, so I can navigate between my fragments. And yeah, I pass as well the identifier of the container that where I will put the fragments. Yeah, I didn't need to put it here. I could put this dependency in the fragment scope because fragment has access to the support fragment manager. So, but I did it because imagine that you want to have start fragment for result thing, and one fragment says, okay, I'm going to start the other fragment for a result, and I get destroyed. So I need someone else that will still be alive to hold the information of who asked for the result. So that's why I like the navigator to be in this scope, the activity scope, to leave while the fragments may be destroyed, to hold the state of the navigation. Okay, so I have my context activity. Nothing is injected here. It's just a container. It will navigate to the container contact list fragment by default. No, by default because of this if, you know guys, right? The if, because there is a state. Maybe there is a different fragment being displayed. So there is a state. I don't want to put contact list fragment by default. There's no state. I put it here. You put it there. It's the first time. Okay, so fragment scope. Nothing new here. Different scope that, again, I can say again. It will, if I annotate a provides method with fragment scope, the instance creator will live as long as the fragment lives because the fragment component is in the fragment. Here's a fragment component. It will have the presenters. So my presenters will leave as long as the fragment leaves, is a decision. You could want them to leave as long as the activity leaves and like have a cache, them cached. But I don't see, my presenters usually don't have state. So I see no need to keep them in memory once their view is destroyed. Their fragment is destroyed. Yeah, so here the plus method again, but in the activity component, passing the presenter module. Again, there's this super dot on attach comes afterwards because of the child fragments. It's the same rationale that we described with the activity. If you have a configuration change, if you have a configuration change, then they may be created before, and you have to make sure you have the component before that. So I add my plus method in the activity component. So yeah, just to state it again, it's important what Rui said. This fragment component will have access to all the dependencies of the activity component. And since activity component is a subcomponent of the application component, it will also have access to all the objects in the application component. Okay, so the presenter module is here with both presenters. Yeah, and they depend on. Now it's interesting because in order to both are annotated. If they were not annotated with any scope, they would be created every time. So every time if there's no fragment scope annotation here, they would be, every time someone asks for it, it will be a new instance, a new instance, a new instance. So that's why we need to annotate if you want to respect the scope. Both of them, yes, no. This one depends on the navigator and the interactor, and they will be satisfied by the other components, respecting the scope in the provides method. Right, that's the logic. So it will be the same context interactor every time because it's annotated with the application scope. And as long as it is the same activity, it will be the same context navigator. Yep. No, then you were responsible for the instance. Yeah. So if no one is pointing to it. No, it's when you set the reference to null, when no one is pointing to it. Yes, exactly. No, yeah, but you have more flexibility. Yeah, it goes together. Okay, so here it's really, straightforward. Here you see another thing that doesn't matter for the talk, but I like to have the attachment and detach of the view in the resume pause. And yeah, there's the inject there to satisfy the dependencies. You see, the reason this component is public, so that's the reason why I have access. It's in the parent class, the base class, just to remember. Same thing with the other one, the detail one. And finally, the fragment component. It will have two inject methods. Again, two, it has to be two. No inheritance here. I couldn't have like a parent class, I don't know, super fragments, and then use the same inject method. I have to have one inject for each type. So I have to have one inject for the tail fragment and one for the list fragment. This is a nice way to put it. So yeah, how long each instance will leave. It's not manager, it's a typo. I started with manager and then I switched. It's the context interactor. Will leave as long as the application scope component leaves, and the context navigator while the activity leaves, and the other ones will leave as long as the fragment leaves. Okay, this is supposed to be one of the advantages. This could be maybe a talk by itself. There's an opinion how to do it here as well. I will show how I would do it, how I would use Dagger to replace dependencies for functional UI testing. Uh, I'll say that the reason why we replace the dependencies, some of the dependencies for UI testing, is because you don't want your tests to be flaky. You want them to always, if your code is correct, it must be green. You don't want false negatives. And if your application, for example, talks to the internet, or even I am kind of a strict guy, so I don't let any I/O happen during the test. So I don't want to talk to the content resolver. I don't want to talk to it in order to grab the context. I will mock it, and I will then say exactly which context will be returned before the test starts, so I can exercise the test and then assert, because then I have full control of first preparing the test and making sure what's the state before the test, exercise the test, and then assert. In order to do that, I have to mock or fake the context gateway. I have to make a small change for that to happen. I don't like to do it. I don't like to change production code for testing. I hate that available for testing annotation or whatever it is. I don't use it. I don't like to have code for testing in the production code. But there's no other way here. So I had to create this create component method and make it open, so I can override it. And then I can change this component, the application component, for a test component, where this test component will have a fake gateway module that will have my fake context gateway. So I create this test application component. It requires the test gateway module. And in that case, I want to have the interactor module. No worries, I want the real one. So I will get the interactor module, the normal one, to satisfy the dependency. It's important thing, all these classes, they live in the Android test directory. So they are not in the production code directory that will be built. All of them that I will show here, they live in the Android test. Of course, the first one that I had to do a little change is the production code one, but all the other ones, they live in Android test directory. Okay, so I have to create a test component application. It will inherit from my real context application, and we'll then override that method, the create component one, and say, okay, no, now going to be the test application component, and then I build it, passing the test gateway module instead of the real one. I use the real interactor module, no worries. Yeah, this is the tricky part. So in order to tell Android, tell Gradle plugin, Android Gradle plugin, that I want when the test runs, I want to have the test component application. I don't want to have the real one. I want to have that one. I have to override the Android JUnit runner and just tell that I want this class to be my application class. And then I update the Gradle build script. telling that the instrumentation runner is my instrumentation runner, the test component runner. I gave it name. You can give whatever name you want. Mock runner, whatever. Uh, yeah, this is the test gateway module. It will create a fake context gateway. It could be, you could use Mockito or whatever mock framework you want to create a mock here. I create this fake. I prefer fakes. Yep, and here's the implementation. This is the nice part. I expose the fake contexts public, so I can access before each test runs, and then I can have a different set list of contexts depending on how I want to exercise the application. So that's why this is public. Also, it has to have a default value that's an empty list, because when the application runs, the onCreate will be called, and the contexts interactor has a setup method that we call, you remember? It will run after the onCreate. And when the test starts, I cannot do anything before that. It will run. It will run before I can change the fake context. So I have to have a default value, so it will not, the setup method will not end up raising a null pointer exception or something like that. So I have to have a default value. And here's the test. Yeah, there's this. This is, by the way, it's using Espresso, the famous framework for functional testing. I hope you use it. The other ones are terrible. So this is the rule from Espresso. Yeah, and then I have to get the application. So I use this instrumentation registry class that is available for me. I get the context. I cast the context to test component application. I get the component, and then I inject the test itself, so I can have the context gateway here. So I can, with the context gateway, cast it to the fake context gateway that I know it is, and then fake my contexts, and then exercise the UI and assert the result, because I have full control of what's going on. Finally, I was supposed to have one more, I guess, because I have to, it's just, I have to add this inject. I have to add to the test application component with the context activity test type. Remember, you have to have one inject per type that want its dependencies to be satisfied. Since I want my dependencies to be satisfied, I have to have an inject with my type in the test application component. That's how I get the fake context gateway. No, I didn't. You can override the provides of modules with that. Is that it? There's no need to override the application, none of that. Mm-hmm. Okay. Okay, nice. What's the name? It's Dagger Mock. Okay. Because actually, I don't know what. That's good that you said that. What other? Because usually, what I want to mock or fake are the slow things of my application. So usually the gateway things, the things that are external and I don't control, and usually they live in the application component. So it's not that hard because of that, you know. Because the way you structure your modules and Do you mock anything else usually? Sorry. Okay, nice, nice, good. Yeah, this is in Dagger 1 it's super simple because of the reflection thing. So you just need to, it's super simple. You say you have a module and you say you need to override the other modules, and but no magic anymore. So no simplicity. So final question: what to inject, what not to inject? I think it's important to talk about it. Another opinion: what you should inject, what you shouldn't inject. And usually, yeah, I inject my interactor, but respecting the architecture, I will inject the interactors, the gateways, the presenters, but I will not inject view classes. I will not inject uh, adapters or layout managers or views. And the reason why I will not do it, I don't want to do it, because the reason why I use dependency injection is because of the abstraction I can have. I can abstract some details and replace them without changing the implementation, the class that actually depends on these abstractions. And in the view layer, it changes so much and often, so I don't care about creating abstractions here. I don't care about uh, I don't know, changing only the adapter without even touching the view that uses the adapter. I don't care about it. I go there and because the designers have a lot of ideas and they change their mind all the time and they change the UI all the time. So I see no value in injecting those classes. So it's just an opinion again. And that's it, guys. Questions? My God, this thing is supposed to help you, right? And okay, yeah. I see no value on that. I checked. It's super complicated. Uh, I don't know what do you think you get from using it that you don't get. What kind of things? Because it has you have to implement a lot of things like it has injector, and I thought, whoa, okay, but why? And then I have this tactic inject method, and okay, I don't know. Do you have any reason specific why you choose the injector? I think yeah, they are trying. I think what they are trying to do is to avoid that you make mistakes that we make as developers. So I mean, so try to guide you in a way of using it. But I think that well, I can research more, but I didn't see any reason why I would use it since it's simpler and I have one less dependence to just use the core of the library. Maybe we can talk later about it and see if it's worth it. Did you get it? I mean, it's you could understand. Everybody followed it. Douglas. Yeah, here I think it's yeah, on detach probably when it will be destroyed when the system doesn't have a reference for the fragment anymore. Yeah, yeah. Yeah, on destroy, not on destroy view. If you okay, if you want to release the dependencies when the view of the fragment is destroyed, you would inject in the on view created. Then we'll say, oh, what I mean, when the view is created, I inject and I get my dependencies. And in on destroy view, I set the component to null. Okay. Then I would say, okay, no one is pointing to the dependency anymore because the view doesn't exist. And then the garbage collector could go there again, go and recover this memory. And then when the view is created again, you pass to on view created, and then you inject new dependencies. Yeah, but it wouldn't be here. It would be in the base one as well. The base in the base fragment. Okay. Because you control. Yeah, you control because it's the life cycle of the component. So it's how long you're going to hold the component instance. If no one is pointing to it, it will be garbage collected. So that's why I told you guys the life cycle of the component is our responsibility. That's why I decide the application component goes in the application point to it all the time, and the other ones goes in the activity and in the fragments, because we control the life cycle of the components. No, because then I'm not solving the problem that I want to solve. I want to solve the problem associated with with the components of Android, with the fact that I cannot inject on them, the fact that Android has its views are destroyed, and while the process is still running, what doesn't happen in iOS? They don't have this problem. They don't have this configuration problem. They don't have this, you know, uh, you change the orientation and then the view gets destroyed, the fragment gets destroyed, the activity gets destroyed. It doesn't happen in iOS. So I'm trying to solve this problem, to how to control the life cycle of my objects, considering that the OS behaves like that. So there are other problems that you can solve with that. Like you said, you can have different scopes based on business logic or whatever. But then I solve those problems in my classes and not using Dagger. Because then it would leak to the other layer. It would leak to the business logic layer, and I don't want it. I want to solve those problems with Dagger. Which scopes? Mm-hmm. How do you control the scope? You set the component to null in a certain moment. How do you control that now I want a new instance? Or I don't get it. What? With when the session is over, what happens? When there's no session anymore, when the user log out. Okay. No, you can, but yeah, but I mean, no, yeah, you can use it. I just choose not to use it. It's an opinion. How do you test it? With UI testing, then. You test business logic with UI testing. So you don't test it. I mean that you don't test the fact that the life cycle of the session is controlled by Dagger, and if it works properly. Okay. Uh, the state, I mean, it will disappear. It depends, but it will disappear, but it will be the state of the view that says that it's loading can be kept by the view itself using the bundle, right? They can say, okay, it's loading. So if I get constructed again, I have to put the loading there. Or maybe your business class will have a state already that says that it's querying something from somewhere. So when you attach here, your presenter will listen to the state of the model that says, okay, I'm working here, I'm grabbing something, and then the presenter will say view loading. So it depends, but you can. In that case, I would say that the responsibility is of the model. So you have to have somehow to know. The model will have to communicate to you that he's doing something.
On? Yeah. Thank you. So Marcel will be around if you have more questions. Dagger is always a good subject. Make people talk for hours and hours. And now we'll have Diogo. A round of applause for him, please. So in the meantime, if you want a beer, there's a, yeah, Andrea. There's a trash can, the yellow one. So please put your bottles inside the yellow can.
Okay, let's start this. Hi everyone. Thanks for coming. This is what makes Android tick. Um, so this presentation will be a little different from what we are used to because we aren't actually talking about just applications. We are talking about the whole platform. And I think there are some concepts that we should know on how Android works that would make us better developers, and we should know about the things that we use daily. So that's the goal of this talk, and I'll I'll promise you that after this talk, you'll know how Android works, like how everything works. And I mean it. My last slide is something like how everything in Android works. And you'll know afterwards, everything. I really mean it. So let's start. So I'm an Android platform engineer. So what we do is operating systems for mobile phones. And we also do Android, like you guys. We do like applications. We have like phone applications, messaging applications, contacts applications, etc., and others. But we do a bit more than that because we also touch the Android runtime. We customize it to the things that we want or we need. We also touch the hardware abstraction layers because we work on new phones, and new phones have newer stuff, like have more buttons, have more sensors, have special features, have dual screens. So Android doesn't support this stuff, so we need to have it. And we also work on the hardware itself, like we accompany the several stages of development for a new phone, and yeah, that's pretty much it. So I've been doing Android for a long time now. I think I remember starting writing an app in 2008 or so, like a Twitter client for an emulator. There wasn't even any device at the time. I've been working on the platform in my free time since 2010, so like 8 years ago. Time goes by. And professionally for the past 4 years. So that's onion-like layer. It's fun to introduce you guys to Android, but it's not actually correct. This one isn't either, but it gives you more of a sense on how things work, how things are separated. You guys work on the layer on top, and you have applications, and you communicate with the Android framework. And typically, that's it. You know, like you call methods and stuff happens. And yeah, and it's normal because the platform is so big, and we have no time. We have to do our work, so we don't have time to invest in knowing how stuff actually works. How does it interact with the device itself? So pretty much everyone here, if not everyone, wrote this line before. What does it do? Anyone? Yeah. That's what happens, but what does it do? Yeah, that's true. Like, so my point here is that's true, and my point here is that most people won't know. Like, start activity shows an activity on screen. That's it, and it's a black box, and it's something that we don't know how it works. You know, we just trust that it does. But who actually runs that code? Is it your application? Usually we say it's the framework, but we are just naming the box. We aren't actually understanding what's behind it. But the framework actually delegates it to someone else, and that's the activity manager. And this is a very simple scheme, which isn't true. That's not how it works. What happens is there's a binary interface to an activity manager, which lives outside your app. That's the one who does the work. But what does the activity manager do? We can go on forever. Like, what does Binder do? How does it work? And one of the points of this talk is to talk about breaking black boxes. You know, all this stuff is reachable to anyone. Like, we can just jump in and see how it works. But sometimes we never do. It's like we go out every day and see the skies, but we never wonder, why are they blue? But you can just go look on Wikipedia. We just don't, but you can. And one of the takeaways of this talk is that we should probably try to break some black boxes. Like, I have a personal goal of breaking black boxes for several stuff that I work on and other stuff. And that's how I improve myself. And yeah, so we'll break some black boxes about Android today. So to make this approachable, because the platform is huge, I'll start by something that you are familiar with, which is your application. Okay, so we have an application. It's basically code and something else, some other stuff that we don't care about, like resources and whatnot. Nobody cares about those. And so here you have an app, and what happens? So on our computers, we pass it through a compiler. It's like Kotlin C, Java C, whatever, and it produces bytecode, like JVM bytecode. That's a visual representation of it. The actual format is binary, but it essentially does the same thing. Like, it loads that payload 0 loads this into the first register, invokes special, calls supper, That's it. Then, still on your computer, it goes through a DEX compiler. It's like DX or D8, new thing. And it turns it into even different bytecode. So the code you write is transformed twice, even before reaching your computer. Then it goes through a zip file, and it zips it together with your resources, libraries, etc., and you have an APK. But then what? Then we have to install it on the device. And installing is a complex process, let's call it that, because your DEX bytecode that left your computer isn't actually what runs on the device at all, since art and since we have more powerful phones now. So what happens to your bytecode? Anyone knows? So that's before installing. It gets compiled again. This is crazy. Your code goes through 3 different compilers before it runs. And there's a reason for this. We are trading off startup time for install time, because your phone is compiling code as you install applications. That's why installing applications is slow. That's it. That's the only reason. And but then, how often do you start applications versus install applications? Usually you start them more. That's why they are optimizing for that. Inside the phone. So when you click install in the Play Store, you download the app, and when the APK reaches your device, the system will unpack it, get the DEX bytecode, pass it through a compiler, an LLVM-based compiler, and turn it into native code, into something like that. So sometimes I see people talking about, well, in code reviews mainly, talking about how our code would be more efficient if we did this or that, but most stuff gets actually compiled down to crap, And sometimes people should invest more algorithmically rather than whether a local local variable in a method should be final. That doesn't do anything, by the way. Anyway, but then again, when our code reaches assembly state, what happens? How does it run? That's a black box as well. But we can know about it. It's easy. Well, it's not easy, but it's easy to know about it if you want to. But we are not getting into that today. It's just too big of a stretch. So when the application is on our devices, what then? So we have compiled bytecode. We have actually an executable by now, and we have a bunch of resources. But your app does need to run. So what happens? So on every single device on the market, there's a bunch of jar files. Don't be surprised by the .jar. There's DEX code in there. It's compiled as well. It's just the extension that's different. And this stuff contains things that you use, like CoroJ is the OpenJDK libraries, like list, set, etc. And the framework contains everything that you use to interact with Android. And framework REST includes resources. Like when you use those kinds of stuff, you're using it from the device. It's not something that gets built into your application. And that's why people break stuff. Like not you people, us people. We break stuff a ton of times. Like we're talking about fragments getting out of scope. It's really easy to, if I'm messing around with that code, call the whole life cycle in a fragment, but leave a reference to it somewhere. And that's on the platform, not on your app. And your app won't die. Like your fragment won't ever be collected. It's a framework level memory leak. This has happened in the past. What also has happened in the past is Samsung changing like Android to.scholar/white to something that's not white. And then you run your app there. You think, oh, I'm safe. This will be white, but it's not. It's like whitish. But why is it different? And some people also think that you compile the framework into your app, but you don't. What you link against is stubs. You have like a jar, which is distributed under the Android SDK, but there aren't method implementations in there. It's just so that you can link against them like a other file, something like that. But those are provided by the device. And then each device does their own thing. And that's why, I mean, show of hands, who has had problems with specific brands of Android phones because of customization by the vendors. A lot of people, I mean, everyone does, because they get to customize everything. So each device has a framework that implements a specific API level, and when you define which API level you support on your manifest, that's how you filter out the devices that you don't actually want to support or the ones that you do. Because that framework will include like Platform API 26 or 25, depending on the version of Android that the device runs. Oh, by the way, feel free to interrupt me at any time. You can make this interactive, it's more fun. Everyone following so far? Yep. So once we have these dependencies, but we also go on. Yeah, you are right. There's a reason why things like this don't happen anymore. Like you still have to deal with it because of all the legacy. There are phones that are 8 years old out in the market. But that's I didn't even talk about it here, but it's a really important question. How do we test that our stuff works? And Google does provide us with a bunch of stuff. The biggest of which is Android CTS, the compliance test suite, whatever. And it includes something nowadays around 400,000 tests that cover not only device functionality, but make sure that you don't break APIs. Like you can't ship a device with Play Store, GMS, etc. If you break those rules, you can't. So those tests test that the APIs do what they should do. Tests that you don't change things like Android white, but there are always new things that you can break. You know? Sometimes it's even, I've seen some cases where people try to fix for the test rather than fixing the root cause of the problem. And then you ship with a broken code, but it fools the test. That happens. And it happens, I'm not even going to talk about it. Anyway, it happens a lot. But yeah, so there's a compliance test suite, and that's how you can make sure that your app will run across a bunch of devices, different heterogeneous devices, but they are validated against the spec, and your code does run like that. So afterwards, your app needs a runtime, because we aren't shipping garbage collectors, we aren't handling memory, we aren't doing any of this stuff. So what does the Android runtime provide to us? The first thing is sandboxing and isolation. So if I write an app, I don't want your app to be able to kill mine, to mess with my data, to do any of that stuff. And this is done in two ways. Well, a bit more, but two main ways. The first is file system level permissions. So your app can write to some places, but other apps can write to the same places that your app does. That's why if you want to share something in your app, you have to do it via a content provider, which works through a binder interface. And that way your application is in control of who can write or not to your environment. And this is achieved by using common mechanisms like file system level permissions and control groups. Have you ever used Docker or know about it? Docker does like three main things. It's a container interface, and it does C groups, control groups, so it separates. Your process can't actually see what other processes do. Actually, sorry, that's namespace. So we namespace your process into a separate environment where it doesn't have any visibility around what's around other apps. So I don't know that your app is running even. So that stops me from interfering with it. And C groups, which means that that's control groups, and that allows me to limit CPU, memory, and other aspects of resource usage. There's also really ingrained security via SE Linux, which stops a bunch of bad things from happening. Like, I'm pretty sure you have heard about Android vulnerabilities, and they affect everyone, but recent years have been better because of SE Linux, because it really, instead of trying to fix things as they happen, what SE Linux does is allows us to say what should happen, and anything outside of that doesn't. So that clears a bunch of It's compulsory nowadays. So yeah, I think it was optional on Android 4.4, KitKat, and it became compulsory with Lollipop. So nowadays, yeah, it's even tested by CTS, the test framework we talked about. No, no. You would if you didn't have control groups. So um, yeah, so I can jump straight to the last bullet because it partially answer your question. Because one thing that the framework gives you, the runtime actually gives you, is garbage collection. So that's everyone is familiar with it. It means grab the stuff you don't need and make room to new stuff that you will need. So it's a continuous process that clears memory that's not used anymore and reorganizes memory so that new allocations are possible. But also enforcing limits, like um, I can tell this XMX is like, have you ever used Java on a regular machine host? Like XMX is like the top most amount of memory that your heap can use. And this also exists on Android, but you don't control it. It's controlled by platform developers like me. And we set it to something that's adequate to the device. That's why your app sometimes can't run on a device like a really, really crappy device because there's not enough memory, because we set it that way. But this has a problem because this has a problem, which is if you allocate natively, you bypass this is done at the Java location level. If you allocate natively, you'll bypass all this stuff. And that's why C groups help, because when you start your application, you will, what Henry does is C group your application into the same value as the XMX, memory-wise, and then set the XMX on the Java garbage collector layer. So even if you try to do that, the allocation will fail. Most likely your application will die because we aren't that good at dealing with lack of memory. Also, so we talked about this before, the runtime gives you implementations to the things that are stubs when you develop, like Java core libraries, the Android framework, etc. Okay? Yeah. Yeah, that's what's actually happening is your app is getting killed because this can happen because of two different things. The first is if you hit a C group limit. The other is if something else on the device needs memory and you are killed by the out of memory killer, the low memory killer action. You can actually see in the logs what's happening. One of those will probably be killing your app for sure. Oh yeah. So if everyone is seeing this on a video, you missed a bunch of interesting questions. Oh well. So we have a runtime, we have code, we have everything, but we have to start our application. The way that happens is the runtime loads the core libraries, framework, core Java, etc. Sets up the garbage collector, which means locating a bunch of memory, organizing stuff. This takes a whole lot of time, and then it loads our app. And if you have ever been a Java developer on a regular computer or backend before, you know that Java is slow to start. It's like one of its biggest disadvantages maybe. And this happens all the time. Like you open up your home, you press like an application, and it loads the core library, sets up the collector. Then you load another one, and it's the same thing over and over again. And this is not a problem for backend applications because they run for a long time compared to the time that they are set up. But this is a problem for Android. And does anyone know how they solve this? Like, this is the same thing over and over again. So on Android, we have this thing called the zygote. And the zygote is like this. This is actually a very poor analogy because I thought, the grandparent feature would, the guy who would create younglings, but it's the other way around. The zygote is like a small cell that gets duplicated. Probably would have been better. But anyway, what the zygote does is do the first things that the platform needs, like the heavy stuff, preloading the framework, loading the native runtime, etc. And then when your app needs to run, we just fork it. Okay? Fork is really fast. It's a Unix construct. In Linux, it uses something called copy on write. Copy on write means that your application will be forked. It will exist separately, and it will use the same memory space as the parent until you write something to it. The trick here is that you never write anything to that part. So you aren't getting any performance disadvantages. You are just loading up stuff really fast. And that's why I know people complain that sometimes applications are slow to start, but this is why they aren't terribly slow. They're just also, most phones have two zygotes running. Anyone knows why? The zygote never gets killed. Have you ever been on your phone and like saw the whole thing dying? Like restarting, but not like a reboot. The device doesn't really power off. It's just software cycles. Have you ever seen this? This is kind of frequent. This happens when either zygote dies or system UI dies. Because zygote has an additional responsibility. Apart from spawning processes, it also monitors them. And when you connect a debugger to an app, you're actually going through zygotes, which is, I find interesting. No, most phones run two zygotes because there's a bunch of native code in Android. Like you have to load OpenGL libraries, you have to load a ton of stuff, and most phones have support for dual architecture, like ARM and ARM64, x86, x86-64, and you need one zygote for each one because otherwise, is any of you shipping native code in your apps, like native libraries, .sos? No? We had talked about this before, and one trick people use to reduce the size of the apps is to provide like just a binary for ARM instead of ARM64, which means that your app will run in a 32-bit zygote. It's fine. There's no practical disadvantage, but that's why there's two. Okay, so all-time favorite, your app gets killed all the time. You know, this is really interesting because most people, when developing apps, and it's fine, but most people just care about configuration changes. Like what happens if I rotate my phone? But in a hostile environment where apps are competing, your app will also get killed sometimes. And some people care about it such that they serialize the states of the app so that even if it gets killed, you go back to the same screen where you were before. I think it's Facebook that does it. They use some kind of scheme where each screen on their app has a URL, like a URL-ish kind of thing. And once they start, they just write it to persistent storage at points. And when the app starts, they just go back and route it to the place where it was before. It's interesting, but the way it works is really simple. Like you launch an app, your app, and then you launch Facebook, which is like this big memory hog. Not a lot of applications are larger than the framework itself, but Facebook is. And then when you want another one, you don't have enough memory. And this is not something that you can control with the runtime garbage collection because it has visibility over the memory of each app. And you need something that monitors the whole thing. And what happens is your app will not get run because it doesn't have enough memory to do it. Instead, Facebook gets killed and Meetup runs. Okay. It's really simple. There's nothing to it. There's nothing you can do about it even except use less memory to avoid being killed. This is something that we as platform developers also can tune because it depends on how much memory the device has, how fast can it free memory. So this is something that we tune as well. Some devices ship with really crappy low memory killers configuration. So sometimes they have a ton of memory, like 6 gigabytes of memory, but your apps still get killed. This is common. So we have seen how Android runs your app and what happens in the runtime. But what's missing is the rest of the platform, like everything. We have touched bits and pieces around your app. But what else happens in Android? So let's play a game. So this will probably be really easy by now, but I call it who owns it, runs it. Like when you call text to .setText, who is running this? Which process? Come on, guesses. Zygote becomes irrelevant once your app runs. Like at this point, your app is running. It's not no longer Zygote anymore. Anyone else? Actually, no. This runs in your app, and yeah, this runs in your app. This doesn't leave your process at all. This is framework code that runs in your app. Why? Because the framework, the jar, bunch of compiled text things, is linked to your app upon startup. It runs on your process. Each application has a copy of the framework in its class path, which doesn't fill a ton of memory because of Zygote. Okay? But it's run by your app, which is interesting. What about this? So this also runs in your app, which is nice. But it doesn't actually run only in your app because there's another thing to it. Your app can't manage notifications. Like even if it was behind APIs, people will find a way to break this and give you like add notifications and so on all the time. Instead, the framework, what it gives you is an abstraction to the rest of the Android system. And there's actually something in the other side called the notification service. And that's what handles your notifications. This is a black box. How does it happen? And this one we'll look into today. Okay. And again, you'll leave this talk knowing how everything in Android works. So your app isn't an island. Okay. So let's show of hands. Who has used any of these APIs before? Notifications? Probably most of you. Like sensors, yeah, camera, location, activities, everything. So if you have used any of this, you have used system services. And they do not live in your application. They don't. And this is important to understand. Because when you call one of these things, it goes outside of your process. Okay, and that takes time. We'll talk about it later. So how do two processes communicate? You have your app, you have the Facebook app, which is crap, and you have the system server. How do they communicate? They are different processes. We must have some kind of inter-process communication mechanism around it. Inter-process is just fancy for processes talking to each other. And in Android, we don't really do message-based RPC, we do method calling. And that's called RPC, remote procedure calling. Okay? It's just a form of RPC, and it's just fancy for calling a method in another process. And this is so important to Android that everything on Android, like literally everything, uses it. This is the glue that sticks Android together. But what we need for RPC to happen, because we have two parties and they have to agree on something. They have to agree on what the method is, what arguments it takes, and what does it return. So we need a contract. We need something that defines all of these specifications and that cannot be violated by any part. We need an implementation. So if I call something like show my notification, I expect someone to actually draw it on the screen. I'm not sure who it will be, but someone must implement that. And I also need a remote proxy. That's how I will communicate with that implementation. And a remote proxy will abstract details of that communication. Okay. So that's why when you call notification manager.notify or whatever, it will marshal your arguments, send them over, and send a response back. But you can get away with doing this without knowing anything about this whatsoever because of a remote proxy. So this is abstract. This is actually valid for pretty much everything RPC. But what's the equivalent for Android? How is this implemented? The contract. Anyone? It's easier. Yeah. So we have an idle file, which is like, probably have seen it, but it's like a Java interface. It defines method names, arguments, and return types. It also has some special additions to it, like you can mark a method as one way, which means that you don't expect a response back. That's pretty much it. Idle is a file format, but it's also a compiler. more like a code generator. It will generate something like for an iNotification manager, an iNotification manager.stub, which contains a bunch of methods that you should implement. Like it's an interface. It's actually an abstract class that you have to extend from, but you get the meaning. Like you need to implement whatever you defined on the idle. And then the remote is something that's generated as part of the idle as well, which is a binder interface it's a wrapper around the RPC mechanism. And that's why it's easy to call a method without knowing how it works. But we'll dive into it. So Binder is the Android RPC framework. You use it every day, and you can't even imagine how much. And even if you use your phone like every day, intents are a thing because of Binder. Everything works with Binder. So let's see an example of an idle. It's like a Java interface, like we talked about. When you want to do a local implementation, you take that iNotification service.stub, and you just implement a method, like actually showed it those. And when you want to use it, you have like this montload of code that gets the notification service from a service manager and wraps it around with the stub interface, and then you can call methods on it. You guys have seen remote exceptions in your code before, right? Sometimes the platform doesn't handle it for you, but every method that you call on the platform, like on the Android.something, that's not local, like it's not the text you set text, will actually trigger a remote transaction, and it will go through a binder interface to somewhere else. Okay? And that communication can fail. The other side can die. And when that happens, a remote exception is thrown. Sometimes it's handled by the framework, like it retries if it's an idempotent operation. Most of the times it will bubble up as another exception, like it drops around. But these are also black boxes, so we know how it works. We have expanded our knowledge, but actually, what's that service manager crap? And where does that come from? Okay, so let's delve into it. So how does Binder work? We know about Binder, like we know it exists. Anyone knows where it lives? Like where Binder code is? Yeah, that's right. It's in the kernel. And that surprises a lot of people because they're like, no, it's just an IPC mechanism. Why does it live on the kernel? The kernel has an interesting view over everything, and it can do a very interesting thing, which is your app can open a file descriptor, like access to a file or a device. In Linux, everything is a file, and it can pass it over to me via delegation. Like you can open, imagine that you are the camera service. You can open the camera app because you have permission to do so, and my app doesn't. And then you can send the file descriptor to me, and I can use it without having the permission to open it. This is important security-wise. So how does Binder work? So we have our implementation, our local implementation, and we register it with a service manager. There's only one. Okay? There's one in the system. When it dies, the system dies with it, and it holds a map. There's a map of the name of the interface to a number, and where does this number come from? The service manager is a context handler for Binder. And that means that it registers itself with the Binder kernel driver. And this is one of the first things that happens when the Android runtime starts. It says, okay, I'm the service manager, and from now on, nobody can tell you that it's a service manager, that's me. And then it's responsible for handling that map. But how do you register yourself with a service manager? By Binder. Everything works with Binder. So what you do is you get a reference to the service manager, which has a special Binder reference. Like it's the first one, it's 0. Okay? And then you call an RPC method on it to register yourself, which is fun. Then from your activity, when you want to get a notification manager, you just call get system service, which at some point queries the service manager for what's the ID of that service, of that Binder interface. It wraps it around on a notification service stub. And then what your app eventually does is call this IOCTL with a transact method. Don't worry if you don't get this. This is like really low level. I made a huge jump here because I don't have like infinite time and everyone wants pizza. So what this IOCTL does, transact means do this transaction, do this thing from start to end. And that one means call a method on the notification manager because that's the ID that I got from the service manager. And call method 0, like the way binder works and the idle transform works is that your method gets numbers depending on the order that they are defined on. So this is 0, this is 1. Okay, that's it. That's why it's 0. And then a parcel. You've used parcels like in your apps. Binder passes parcels around, and that's why you use parcels in your app because everything bubbles up to the framework. That's what the framework knows how to handle. That's how it can pass stuff around. And you just parcel that string and send it over to Binder. This is a one-way method. We didn't define it as such, but I just decided, so we don't expect any return. Otherwise, we would get a return from Binder eventually when the notification manager replies. So this is important because sometimes we call a method on a binder and we have to wait for the response. Things aren't synchronous. They aren't. What your app is doing, even if it's hidden from you, is looping, waiting for something to happen. At some point, you'll get a response and you'll return. That's why you shouldn't use like binder transactions or framework method calls on draw, for example, because it would take a long time. An IOCTL is called a context switch as well, because actually it causes a context switch because it will changes the context between your process and the kernel. And this is a very expensive operation. Like this is slower than accessing memory. This is slower than branch mispredictions. This is slower than a bunch of stuff. I probably compare it more to writing something to disk than accessing memory. So just so you know that it's a heavy operation. And we should know that we shouldn't call it if it's a tight loop or something sensitive unless we really need to. Questions? Is what, sorry? Yeah. So one thing that happens, which is interesting, is Android tries to optimize some of the stuff for you. So for things that are known to the system, they are cached. So I already know that that is one, so I won't probably query the service manager. But the first application that does, yeah, it will take that hit. This is not so like seconds slow, but it's so like 10 milliseconds slow. Okay, maybe even not that, but it's slower than like a local method call. But this gets hidden easily if you call a framework method thinking that it will be executed locally. You think it's instant, but probably it's not. Oh yeah, oh yeah. But I mean, there are context switches all the time. When you touch a screen, there's a context switch. They happen, they are fast, but let's say you are looping or drawing, that might be the cause that your draw process is skipping. Yeah, definitely.
It a good option to access to this cleaning, or is it unnecessary?
It's a good question. So I don't think they got everything. So the question was, we sometimes get notifications on our phones saying that applications are doing too much work or are using too much memory, and to fix it. Like this is very popular in Samsung and LG phones. Yeah, so you have an option to fix it, and what that does is kill the apps. Okay, so there's nothing more to it. It will kill the apps. And I mean, I'm not a huge fan of killing everything. It's too chaotic. Killing is not a graceful process. Your app will not get something like, oh, your app is going away. No, it will get killed. And sometimes that can cause weird things. If you don't do persistence right, it will cause some file to become in an intermediate state. And if your app can't handle that, it will crash next time. So I'm not a big fan, but it does happen even if you don't click sometimes because of the low memory killer. It helps with misbehaving apps. Sometimes I get a notification on my phone saying, this app has been using like 1% of battery for the past 3 hours. Do you want to kill it? Hell yeah, I don't want that thing running. But wholesale killing of everything, I'm not a big fan of. Some people say it helps. I'm not sure. Is the mic?
when you swipe the apps, it depends on the implementation, how if the process is going to be killed or not.
So in stock Android, the application gets killed. Some some people change it, like some devices change it, but it's not something that's tested by CTS. So each vendor can have their own thing. But if you want to assume one behavior, most people won't change it, so it will most likely kill your app. Oops. Okay. So I promised you, you'll know how everything in Android works. So you have your app, you have framework abstractions, which is the jar where you call methods on. You have the service manager where you get services from. You have the binder, and then you have the camera server if you want to open a camera, display camera in your app. You have the Bluetooth if you want to search for Bluetooth devices or associate or wherever, and anything. Like this is literally how everything works on Android. Like if someone asks you tomorrow, hey, do you know how calls work on Android? Oh yeah, the dialer app. You type in a number, you press a button, and it makes a binder call to the telephony stack, which eventually reaches the modem via binder as well, and the phone gets running, the call gets running, which is awesome because now we just expanded our definition of how things work on Android. And we can keep doing this for everything, which is awesome because it's open source and we can just look into it. Okay? You don't look convinced, but it's true. And I've met platform developers who don't realize this. And you probably know more than them by now, which is awesome as well. So how would you become a platform engineer if you wanted to be one? Which is interesting. So turns out most of you already are because the platform is the whole thing. And in my company, we do a bunch of application stuff. So you guys got that covered. You are application developers. You also have the framework covered. I mean, you've been using these things since forever, like content providers, etc. It's just the other side of it. Also Java. It also uses the same libraries, but it's implementing slightly different functionality. So the runtime is slightly more complex, but we talked about it today. We opened a few boxes. Not enough, but enough to get you started, or curious at least. And then we can go down the stack and open those boxes as well. And well, sky's the limit, you know. It always depends on how much time you want to invest or what you want to learn, but it's a pretty interesting thing to learn. So how do you start? You have to compile Android, and that takes time and patience, and 16 gigabytes of RAM at least, 32 ideally, and 100 gigs of disk more ideally. And the platform is huge, but in the end, it's just piecing together different components. They are big, but they are just programs. Sometimes I mean people are like afraid of touching the Linux kernel. Just a program, man. It's like it runs when your phone starts, but it's a big one. Yeah, there's complex stuff in it. Yeah, but most of it is crap. Most of it is like just passing stuff around. And that's the same for pretty much every component in Android. And just look into it. It's simple. And so there's a website from Google which tells you how you can compile Android, and it's extensive but easy. Like you can get going in like 20 minutes or so. And it involves like fetching a bunch of stuff from the internet and setting up your environment so that you have the compiling tools. And then you can run your own Android build, like your own operating system. You can even call it whatever you want on a Pixel device, if you use the OSP, or on an emulator. If you want to run it on other devices, there's also Lineage OS, which supports a bunch of different devices in an aftermarket way. And platform development is really fun. Like, how many of you use Min SDK version 27? Really? Why? How? That's not 27. Like you. I mean, how many of you use 26? Yeah? Most people will be stuck with like 20 for the next 5 years. Platform development can also be dangerous. Not the bad dangerous, but the fun dangerous. Like you get a war story to tell. Go ahead and read that. That's a method you can call as a platform developer. That's a method I've called as a platform developer. Not because I wanted to, but because I changed the logic of some stuff on that run. That was fun. So what that does is it clears your user data, so everything gets cleaned. Luckily, you did this mistake on development device. I ran Android, custom Android on my personal device for a long time. I've done this on my personal device. Fine, huh? So how does reboot wipe user data work? Also black box, that's homework. Okay. Probably binder. So there are two takeaways from this talk. The first is binder is how everything works, and now you know how it works, so you know how everything works. And also probably more of a life message, if I can pass that, which is don't stop working black boxes. Like, I know how to do this. Yeah, but there's always something, some satellite thing that I can learn to be better. And yeah, so never stop doing it. So this is time for questions. By the way, we have an Android LX Slack group. Some of you are there. There's a platform channel which exists since today, and it's really lonely in there, like lonely. There's only me. And if you have questions or you want to know more, or talk about whatever, feel free to join or send me an email. I'll be available. So, questions?
When you wish to sell your smartphone, you generally reboot to the factory state in order to give something clean to the buyer and also to delete what are your personal information. So from what you said just before, it is not sure that the system is clean from your personal data. Is it true?
So when you buy a new phone, people aren't flashing them manually. There's a factory process that goes with making a device. It's usually right after the assembly phase where you flash testing software on it, and then it gets cleaned, like wiped clean with something stronger than that, and flashed with a golden image, which is the production software. So what you will get is a clean, as it should be, device. I'm sure you've read about people getting test devices or devices with test software flashed on it or with pictures of people on the assembly line. That's sometimes human error, it happens. Sometimes people forget to pass it through the cleaning station. So if you are giving your device to someone else or selling it secondhand, you should do a factory reset, and it does clean your user data. There's nothing there. Most phones will do it securely, even like they will wipe the flash in a way that it's not recoverable. Most recent phones, medium range to high range, will do it. Some older ones might not, because it's a very expensive process on slower hardware, because you have to go byte by byte. But the new ones actually support a different way, which at the control level can wipe the whole drive, and that's secure. It won't factory reset your device in the sense that the original software that came with it won't be flashed again, but the updates, it will get the last updates that you did to the device. But your user data should be fine.
Thank you. Great talk. When we start studying about Android, we know there's the Dalvik, which is like a later version of the JVM. And later it appeared the Art. So Art is not Dalvik, or is something on top of Dalvik?
Yeah, so Dalvik was created to run DEX files, and it did so. If you use Android like 1.5 or something like that, Dalvik was an interpreter. It would take your DEX file and just run it like a Python interpreter or something like that. Then by Android 2.2, I think they added just-in-time compilation, which means grab the code that's hot, that runs a lot, and turn it into native code. In recent versions of Android, I think 5, they introduced Dart and deprecated Dalvik. So it's a whole different compiler and runtime, which turns your DEX code into something native. In some devices, it will not compile the code ahead of time. It will also interpret it and do the cheating process. But Art is a completely different implementation of the same kind of virtual machine that will run DEX bytecode.
Okay, so you said that when you compile, the code gets into native code, right? But security-wise, is there any problems with that? Because native, so it's a VM, you have some degree of control and security, right?
Yeah. So, I mean, it's not any different than how your app would run because you can just add libraries to it. You can use native code on Android, and it runs on the same level. So the security isn't based on we shouldn't do this natively because it can cause security problems. It's more like let's do this securely so that it's no problem to execute native code. So it's the other way around. But anyway, what happens in this compilation step is usually very deterministic. So it turns DEX into native. It gets thoroughly tested, hopefully. And in the end, it will produce correct results. This has been the default since Android 5.0. So it has been around for a long time. There have been bugs with it, and there still are for sure. But I think most people you ask would say that it's a correct implementation at this point.
Yeah, also because you program me, yeah.
No more questions?
At first, I said that I read that there's this virtual binder. So because you say start activity, and sometimes it's in your own process. It's just starting another activity, and it would be too costly to go to the kernel to do that, and go talk to activity manager and do interprocess. So there's any optimizations regarding that?
Yeah, so the hot kind of methods get combined together in binder transactions. So instead of like doing one thing and then another thing, it will get like there will be a block of transactions that run at the same time. That's doable. That allows you to do things without paying the penalty each time you invoke, and the framework does that to some extent. But other than that, most work has been going into making binder really fast. Like in recent Android versions, binder even has a spread and fan out kind of construct, which means that it can do asynchronous operations, like these bulk operations, much more efficiently without going to the kernel and back again. And there's a really expensive operation. Like, have you ever used the sensor listener? Like, there's a bunch of sensor listeners around, and when something changes, it has to go around and notify all those. That's what fanning or spreading kind of strategy does. And recent optimizations have gone towards that. But other than that, it's mostly taking care as a developer, even as a framework developer, to not introduce a ton of IPC over the whole process. There are optimizations that you could do. I mean, I'm not sure if they are done. To be honest, I have no idea. The framework is huge, and I don't even claim to know 1% about it. But it's possible to do optimizations where starting activity would never leave your app. But then once there's a new window, it will have to leave your app anyway. Okay, so there's a bunch of IPC things running when.
I mean, the OS knows that both activities live in the same process, so it would be stupid to go to the kernel to talk to them.
Yeah,
you know?
Sure. Yeah, there are plenty of optimizations that are possible and even maybe implemented. I have no idea, to be honest. Thank you.